Okay, welcome to Foundations in Pre-Calculus Math 10 with Mr. Johns. We are just going to start Chapter 4, which is about roots and powers. And so, here we go. So this section is section 4.1, which is estimating roots, or square roots. But we need to understand the relationship between squares and square roots, or cubes and cube roots. So let's use the value of 4. If we think of 4 squared is like saying 4 times 4. 4 multiplied twice. And this is going to give us 16. So then blank is the square root of 16. So the square root of 16 is what value multiplied by itself will give us 16, and this is 4. So the square root of 16 is equal to 4. Or the square root of 4 squared is also equal to 4. So square root and squared are inverse operations. Let's draw a picture to represent this. If I draw a square with sides 4 long, 4 by 4, the area of the square is 16 units. Here, 4 cubed is like saying 4 times 4 times 4. So this is equal to 64. So then blank is the cube root of 64. So what multiplied by itself 3 times will give us 64? This is 4. If we were to draw a picture to represent this, we can think of it like a cube. And this cube will have all sides being 4 units long. Oops. And if you count how many squares are in the whole thing, it's 4 by 4 by 4. In the whole cube, there's 64 units. 4 to the power of 4, that would be like 256. So the fourth root of 256 is like saying the fourth root of 4 to the power of 4, and fourth root and to the power of 4 are inverse operations, so this is 4. Now what I'd like you to do is take the time to fill in this chart. Here's our x value, 1, and I want to know what 1 squared is. 1 squared is equal to 1, 1 cubed is 1, and 1 to the power of 4 is 1. 2 squared is equal to 4. 2 times 2 times 2, or to the power of 3, is equal to 8, and 2 to the power of 4 is 16. Keep going, fill out the whole chart so you're aware of the cubes, the squares, and the fourth powers of all these smaller numbers. Now, having filled out the chart, when I ask you to find the square root of 25, well, what number squared would give us 25? And you know from up above that 5 squared was 25. So the square root of 25 is 5. Now, when we look at the square root of 42, basically we notice that it's not a perfect square from our chart above. So to estimate it, what we're going to do is look at the 2 perfect squares on either side. 36 would be like 6 squared, 49 would be like 7 squared. So the square root of these 2 values is what we're going to compare it to. The square root of 36 is 6, and the square root of 49 is 7. Well, it's somewhere in between 6 and 7. So we're 6 digits away from 42 here, and 7 digits away from 42 there. So we're a little closer to 6. So if I was to estimate, I would say about 6.4. Now if I get out my calculator and find the square root of 42, I get 6.48074. So I'm going to round it to 2 decimals because there's a 0 following here, and I'll put a dot above my equals just to note that I've rounded my answer. So here I've estimated and evaluated. With this one, because it's a decimal, to get 2 decimals, I will need 1 decimal in the answer. So the square root of 49 is decimal 7. Because the square root of 49 is 7. And here, 0.7 times 0.7 is decimal 49. In this case, we could consider this like saying square root of 9 over the square root of 64. Both of these are perfect squares, so the square root of 9 is 3, and the square root of 64 is 8. When we look at E, we're trying to find the cube root of 8. And if we look in our chart, 8 is the same as 2 cubed. So the cube root of 2 cubed, well, those are inverse operations, and this is just 2. Well, if we're estimating the cube root of negative 21, we haven't dealt with negatives yet, but it's okay as long as this root is a odd number, because then we'll have an odd number of negatives, which will give us an odd value. So if I look at the two perfect cubes on either side, I can look at 8 or negative 8 and negative 27. Because negative 8 would be the cube root of negative 8 would be negative 2. The cube root of negative 27 would be negative 3. Now in this case we are 13 digits away from negative 21 to negative 8. We're 6 digits from negative 21 to 27. So we're a lot closer to negative 27, and so we're a lot closer to 3. So for my estimate, I'm going to say about 2.7, and this value is negative. So this is my estimate. To find the cube root, I'm going to take negative 21 and punch it into my calculator for the cube root. Now this can sometimes be tricky to punch into a calculator, but it should be a second function of something. The value is 2.75892. So I'm going to say 2.76, round up on the hundreds, and put a dot above my equals to say I approximated, and circle my answer. If you can't find it on your calculator, you can actually type negative 21 to the power of 1/3. Now be very careful, but the power of 1/3 is the same as the cube root. And we'll learn about that later in this chapter. So now I want you to try these ones. Your assignment is section 4.1, numbers 1, 2, and 3. If you need any help, just ask. Good luck.